The next step we have after doing compound inequalities are solving absolute value equations and absolute value inequalities. These essentially amount to compound inequalities once we set them up appropriately. So that's something to keep in mind as we go forward. Remember that the absolute value of a number is the distance that number is away from 0 on the number line. That means it has to be positive. Okay? Remember the expression inside the absolute value symbols can be positive or negative. What that means is the absolute value of 4 is 4. The absolute value of negative 4 is also 4. So whether it's positive or negative on the inside, when we actually take the absolute value symbol, it becomes positive. This is a formal definition over here of the absolute value function. Don't be overly concerned with that, but just know that we can have a positive or a negative. That's where a lot of our information here now will come from. We'll start with an absolute value equation. On the left here is a general statement for any absolute value equation. You have to solve 2. To get rid of the absolute value symbol, we take the inside equal to positive c, the inside's positive, and the inside is equal to negative c. It's equal to a negative. So as we look here, we solve the absolute value of 2x minus 5 equals 9, and we're going to solve that 2 different ways. And we'll separate them by the word or. Okay? So we think that the expression inside is positive here, 2x minus 5 equals positive 9, or that expression on the inside, 2x minus 5, is negative 9. Those are the 2 equations that we will need to solve. We solve them as we did equations several sections ago. So on this left, we'll add 5 to both sides. 2x equals 14, and then we'll divide by 2, and I get x equals 7 on the left side there. Again, basic equation. The inverse of subtracting 5 is adding 5. The inverse of dividing or multiplying by 2 is dividing by 2. Hopefully you'll notice that our steps need to be the same on the right side here. I get 2x equals negative 4. Then I divide by 2, just like I did on the other one. This time, however, I get x equals negative 2. So I have 2 possible solutions. I have x equals 7, which if you think, 2 times 7 minus 5. That's supposed to be 9. It's the absolute value of 14 minus 5, which is supposed to be equal to 9. We get the absolute value of 9 equals 9, which we know is true. The same thing works out for negative 2. It's just whatever we get on the inside will be negative 9, but we'll take the absolute value of it and make it positive. So we take a look at this example here. We have, to solve this, we have 2x minus 7 minus 5 equals 4, and we have the absolute value of 2x minus 7 minus 5 equals 4. So now what we have to do first in a problem like this is get the absolute value system or absolute value symbols by itself. So in order to do that, we'll add 5 to both sides. Okay? So this one, we want to think 2x minus 7 is positive. So 2x minus 7 equals positive 9. This one, we add 5 to both sides. Get the absolute value of 2x minus 7 equals 9 again. This one, we're thinking 2x minus 7 is negative. It's equal to negative 9. Now hopefully we see we're back to just where we were in that last example, and we'll add 7 to both sides. I get 2x equals 16. The inverse of multiplying by 2 is dividing by 2. I get x equals 8. And the next step on the other equation is to add 7 to both sides. 2x equals negative 2. You divide by 2, we get x equals negative 1. It's got to be one of those two in order to make our absolute value equation correct. Absolute value inequalities. We have and inequalities occur when an absolute value is less than a number. So if we have absolute value of x is less than or equal to 8, that's an and inequality. What that means, that particular expression means the distance between x and 0 must be no more than 8. So that would mean, that we'd have negative 8 is less than or equal to x is less than or equal to 8. Because the distance x is away from 0 can be no more than 8. Or inequalities occur when the absolute value is greater than a number. Just like we see here, the absolute value of x is greater than or equal to 8. That means the distance between x and 0 must be no less than 8. So that means x has to be less than or equal to negative 8, which would put it on the outside there, or x has to be greater than or equal to 8. Keep these simple inequalities in mind here as we move on to a couple of examples. A couple of and inequalities. We have x minus 4 is less than 3, and x minus 4 is greater than negative 3. We have to solve both of those. So we have what's on the inside is positive, what's on the inside is related to a negative, and we always have to switch that symbol. And we'll see that here with all of our examples. From here, it's a simple inequality. We add 4 to both sides. I get x is less than 7, and I add 4 over here. I get x is greater than 1. Though this is okay, the way you'll see your answers written here is 1 is less than x is less than 7. So we'll solve them this way and then write our compound inequality just like that. If we look, 1 is less than x here, x is less than 7 here, we are able to put those together. Next example. We have x plus 6 is less than 8. We just rewrite it without the absolute value symbol. And x plus 6 is greater than negative 8. Solve these. Subtract 6 from both sides. I get x is less than 2. And subtract 6 over here. I get x is greater than negative 14. So let's put these all together. Negative 14 less than x less than 2. Final answer. Remember, x has to simultaneously be greater than negative 14 and less than 2. So like 4 would not be an answer to that last inequality. Or inequalities. This first one, again, just like we did with the equations, we have to get the absolute value symbol by itself. Here we have minus 3, so I have to get rid of that. 2x plus 1 is greater than or equal to 9. Again, we have to set up two inequalities. 2x plus 1 greater than or equal to 9, or we have the negative 9 here, and we'll have to switch the sign. 2x plus 1 less than or equal to negative 9. And now we solve these just as we did before. Subtract 1. Subtract 1. 2x is greater than or equal to 8. Divide by 2. We get x is greater than or equal to 4, or we subtract 1 from both sides. 2x is less than or equal to negative 10. Divide by 2. X is less than or equal to negative 5. So it has to be one or the other there. It does not have to satisfy both, because there isn't a number that is less than or equal to negative 5 and greater than or equal to 4. It does not exist, so you cannot do it. Last example, 3x minus 3 is greater than or equal to our positive 6, or 3x minus 3 is less than or equal to our negative 6. Solve them. Add 3 to both sides. 3x greater than or equal to 9. Inverse of multiplying by 3 is dividing by 3. I get x is greater than or equal to 3. Or, same steps. We'll get different numbers though. 3x less than or equal to negative 3. And then again we divide by 3. I get x is less than or equal to negative 1. Two different answers. It has to be one or the other. Final summary. I'm going to cut this off here so your video isn't quite as long, but you can pause this. This is just a summary of everything we've done. Got a couple days of practice with these because they can be a challenge. See you tomorrow.